Black hole information paradox. The black hole information paradox asks the question, does information disappear when it falls into a black hole, violating the laws of quantum mechanics? From what we know about them, black holes consume everything that gets too close, including planets, stars, light, and even information about their own formation. As a result, whatever goes in is thought to be lost forever, especially if a black hole dies, which would cause everything inside to evaporate. However, according to the laws of quantum mechanics, nothing, including information, can ever be lost. The car keys I lost 5 years ago beg to differ. However, there may be an answer to the black hole information paradox: wormholes. Yep, they might actually exist in real life. According to one theory, black holes are connected to other black holes via wormholes, which would then carry the information soon to be destroyed to another black hole, therefore keeping it safe forever. But what are black holes exactly? A black hole is formed in space when a massive star collapses in on itself. When that happens, it creates a tear in space-time. Anything that gets too close or enters what is known as the event horizon is already at the point of no return and is doomed to fall in. Not for nothing, but Event Horizon is also the name of an awesome and underrated movie from 1997, starring Sam, the surly dinosaur expert from the best Jurassic Park films, Neil, and Lawrence, Morpheus, but also lied about his age to get a role in Apocalypse Now, Fishburne. So check it out. Albers Paradox. Next, we have Albers Paradox, aka the Dark Knight Paradox, asks the question, why is the sky dark at night? Or to be more specific, is that a static, infinitely old universe with an infinite number of stars distributed in an infinitely large space would be bright rather than dark? Sadly, as you probably guessed, the Dark Knight Paradox has nothing to do with Gotham City's Caped Crusader. If the theory was correct, then the dark night sky would be as bright as daylight, which sounds maddening. The thing is, the theory has a major problem in that for the Dark Knight Paradox to be correct, that would mean that the universe reached a point where it stopped growing. As a result, all of the stars have settled into their spots and won't move, kind of like a person when they find their favorite spot on the sofa, when in reality, the universe is constantly expanding. As well, keep in mind that new stars are being born while other stars die. Think of it as a wall of light bulbs. Some burn out, and some get replaced. Like with most paradoxes, people have suggested a lot of solutions to the problem, including the writer Edgar Allan Poe. Poe believed that our ever-expanding universe is too new for the light of distant stars to have reached Earth yet. Another potential reason the sky is dark at night is that some stars simply die out before their light reaches Earth. Why do you think the sky filled with stars gets dark at night? Tell us in the comments below. Meanwhile, we're going to tell you about the Fermi Paradox. The Fermi Paradox. Where are the aliens? The Fermi Paradox asks the simple question, where are the aliens? In other words, there are roughly 10 billion planets in our own galaxy that could support life. So, why haven't we found any evidence of extraterrestrials? In all of human history, we haven't found any evidence of life in the universe beyond our own. Are we really alone in the universe? See, we know for certain that the Milky Way galaxy, home to planet Earth, is 100,000 light years in diameter. To put that into context, it would take about 200,000 years to get from one side of the Milky Way to the other. Then consider the fact that in that expanse, there are 100 billion stars. It's estimated that about 10% of planets are Earth-like. Yet, if there is alien life out there, we haven't heard a thing from our intergalactic neighbors. Nope, not a peep. No postcard or even a forwarded spam email. No little green men running down the street trying to take over the planet or offering us glimpses of impossible technology way beyond our own. In other words, tons of movies and books about aliens have lied to us. If there is life on other planets, why haven't they contacted us? It should come as no surprise that people have tried to present many different answers. As the story goes, at the same lunch meeting, Enrico Fermi himself presented a few theories, such as interstellar travel was impossible. Maybe there is an inhabited Earth-like planet out there, but they haven't figured out how to travel among the stars yet. That could mean that there's a whole planet of extraterrestrials who are about where we are when it comes to technology. If it was possible, alien civilizations had judged it not worth the effort. Some believe that maybe there's an extraterrestrial civilization that could have achieved space travel. But instead of building spaceships to explore the heavens, the ETs felt it just wasn't worth the effort. Perhaps they were focusing on solving their own planet's problems. Technological civilizations did not last long enough. Finally, Enrico wondered if a civilization of ETs did become technologically advanced, but they didn't last long enough to leave a record. Keep in mind that there have been entire civilizations of people on Earth that disappeared virtually without a trace. Some societies are like the stars. They start off small, then build, then something happens and they go supernova or implode. If it happened on Earth, it could have happened on other planets, right? Others think that maybe we are just too far from our potential neighbors. People could live on farms a mile or two from each other on Earth and never interact. So it's possible. Meanwhile, others believe that ETs have been on Earth all along, and we don't know. You know, hiding in plain sight. For all we know, there may be aliens who have the ability to travel to our solar system, but instead of looking at Earth like a destination, we're seen at best as a backwater intergalactic truck stop that's not worth more than a quick visit. The thing is, we'll probably never know for sure. One thing we do know for sure is our next paradox is really cool. The Faint Young Sun Paradox. According to the Faint Young Sun Paradox, 4.2 billion years ago, the sun was 20 to 30 times less powerful than it is now. Yet, it was still warm enough to support life. Instead, due to the weak sun, the Earth should have been so cold that no life could have existed, and any water would have been frozen solid. Yet, we have evidence to prove that there was, in fact, water on Earth that far back. So how could that be? It shouldn't surprise you that there are just as many opinions on this subject as there are stars in the sky. It's believed that stars, like our sun, get more powerful as they age. If both things are true, then there must be a reason that the Earth was warm enough for all the water not to freeze, right? One theory suggests that a layer of greenhouse gases in the atmosphere warmed up the planet. We may never know the answer to this one. You could thank physicists Carl Sagan and George Mullen for this brain teaser, since the pair first came across it in 1972. We may never know the answer to this one, but as long as there is at least a pair of docs, pronounced a paradox as in a pair of docs, attempt at a joke, coming up with solutions, we're always getting closer. Now wait a minute. Before we continue, please give us a like and share it with all your friends, family members, and even enemies. They might want to learn about space paradoxes too. Also, make sure you subscribe to the channel to keep up to date with all the great content we put out. Now, back to the video. Celigers Paradox. Next, we have Celigers Paradox, which states that because gravity exists in an infinitely growing universe, stars and planets shouldn't exist. Wait, what? In the 1800s, a German astronomer named Hugo von Seliger proposed the idea that gravity should be at equal strength in the entire universe, meaning that no one spot in the universe should have enough gravitational pull to draw things in like gases that make up stars. In other words, if gravity pulls something in one direction, there should always be an equal amount of gravity pulling it in the opposite direction. In that situation, nothing would ever move. Instead, the way gravity works as we know it is that the closer an object without its own gravity, like an asteroid, is close enough to something that does have gravity, the more it is pulled toward it. On the flip side, the farther away an object is from something with gravity, the weaker the gravitational pull is. It makes you a bit marshmallow-headed, doesn't it? Well, think of it this way. Gravity keeps us on Earth, but the farther we go from the Earth's gravitational pull, the easier it is to float away into space. The Grandfather Paradox. Now we come to the granddaddy of all time travel paradoxes. Grandfather Paradox asks the question, if I went back in time and accidentally killed my own grandfather, does that mean I would cease to exist? The short answer is no. It's believed that if a person or an object goes back in time, a new timeline is created upon their return to their present. As a result, the current timeline a person initially left wouldn't be affected. But if said timeline traveler is able to jump forward again in time, that timeline would be different. In other words, the rest of us wouldn't be affected. Think of it like the Marvel Universe. Every time a person goes back in time, they create a new starting point for themselves, and when they jump forward, they are in a new world in the multiverse. Maybe this will be the one where instead of Spider-Man, New York is protected by Spider-Pig. The point is, at least for now, all our grandfathers, and by extension all of us, are safe from temporal meddling. For now. The grandfather paradox and slight variations of it have been popular in science fiction since at least the 1950s. And though grandfather paradox sounds like pure fantasy, real physicists and philosophers have looked into this. In fact, in 2010, a professor at MIT named Seth Lloyd conducted an experimental computer simulation that involved sending protons 1/1000th of a second back in time. Our advice? If you ever go backward in time, just pretend you're in a museum and look, but don't touch, just to be safe. The twin paradox. Finally, we have the twin paradox, and it poses this question. If there are two identical twins, and one twin travels to a distant star at near light speed and returns, while the other stays on Earth the whole time, will the twin who went to space still be the same age as the twin who stayed on Earth upon his return to Earth? Or would the twin who went to space be younger than the twin who stayed on Earth? In large part, the twin paradox was born from the work of some former patent clerk named, note, maybe purposely mispronounced his name a few times first, Einstein's theory of special relativity. Time should pass slowly for the twin, whose craft travels at light speed, that it would be for the earthbound twin. As it turns out, thanks to twin brothers Mark and Scott Kelly, both astronauts, we have an answer. In short, the theory has been proven to be correct. Well now, there's just a mind-crushing amount of math involved in this paradox. It is way too much for us to go into here. In 2015, astronaut Scott Kelly was stationed at the International Space Station for 1 year. Meanwhile, his identical twin, Mark, who is also an astronaut, stays on Earth. When Scott returned to Earth, a whole bunch of tests were done on the brothers to see if anything had changed. As it turned out, a lot had changed. Among the biggest changes between the two brothers was the fact that Mark was now the big brother. While Scott was in space, the earthbound Mark aged a total of 8.5 milliseconds more than his brother. Pretty cool, right? So for those of you with an annoying older sibling or twin, the solution to your problem is clear. Send them to space for at least 1 year, and then you will become the older sibling.